नमस्कार, स्वागत है आपका एडुसेट लेक्चर में। जैसे कि आप जानते हैं, हमने इस हफ्ते क्लाइमेट और मॉनसून की श्रृंखला प्रारंभ की है और इस पर चर्चा करने के लिए हमारे साथ स्टूडियो में मौजूद हैं डॉक्टर आर.बी. सिंह, जो कि वाइस प्रेसिडेंट हैं इंटरनेशनल ज्योग्राफिकल यूनियन के। इन्होंने डिपार्टमेंट ऑफ ज्योग्राफी, दिल्ली स्कूल ऑफ इकोनॉमिक्स, यूनिवर्सिटी ऑफ दिल्ली में टीचिंग और रिसर्च भी कंडक्ट करते हैं और साथ ही ये IUGU नेशनल कमेटी ऑफ इंडियन नेशनल साइंस एकेडमी के मेंबर भी हैं। तो इस चर्चा को आगे बढ़ाने के लिए मैं डॉक्टर आर.बी. सिंह का हार्दिक स्वागत करती हूँ। नमस्कार।
थैंक यू मैडम। डियर व्यूअर्स, in continuation of our subsequent 4 lectures, today I am going to discuss with you climate and atmosphere. In the era of climate change, and we are getting the impending climate change, we are getting maximum sign and signals from all over the world and even within our Indian subcontinents that climate is changing, and it is very important for us to understand the different component of climate, and then subsequently we are going to also discuss about our local important climatic factor like that is monsoon. Apart from that, also we are going to discuss climate change issue at the end of our discussion. So today largely I am going to focus on the components of a climate, different factors influencing the climate, composition of atmosphere, then a climate classification, and various institutions involved in the whole climate change research in India. This climate is usually defined as a average weather. One can see a very close relationship between the weather and the climate. It is a statistical description in terms of mean and variability of relevant quantity over a period ranging from months to thousands and millions of years. The classical period for classifying the climate and understanding the climate, the period identified by the WMO and also adopted by India is 30 years, largely by the World Meteorological Organization. Climate can be contrasted to weather, which is the present condition of these elements and their variation over shorter periods. So weather denotes the shorter duration, condition, a state of climatic condition, but on the other hand the climate depicts the long term a state of climatic situation. Difference between climate and weather is usually summarized by the popular phrase, climate is what, I quote, climate is what you expect, weather is what you get. Then I would like to make distinction between these two very important factors, weather and the climate. Weather is an instantaneous atmospheric condition. It is but on the other hand the climate is an average atmospheric condition. Weather can change rapidly within even less than 1 hour. On the other hand, climate sustains over a period of 30 years as defined by World Meteorological Organization. Weather prevails over a short area. On the other hand, the climate prevails over a large region, even the country or the broad region like a Himalaya or Indian desert region. Weather has only limited predictability. On the other hand, climate is almost constant. Last, but that is a very, very important point, the weather depends primarily on the density of temperature and moisture, and looking the differences between one place or the another. On the other hand, climate depends on latitude, distance to the sea, vegetation, presence or absence of mountains, particularly the hills or the topographic factors, and together with some other geographical factors. Now, I would like to bring before you various climatic variables. It is very important to understand climatic variables. While experiencing the climate as hot or cold, we realize that the climate is the result of a delicate balance between several elements, which include atmosphere, largely the gaseous elements of the atmosphere, then the water system, living organisms, then topography, and here particularly the altitude and geographical factors are very, very important influencing factor on the climatic situation. These elements determine various factors that govern the climate. These factors are called variables. More specifically, I would like to call the climatic variable. Of these, some of the important variable I would like to here elaborate. Rain, that is a very important, because out of the all variables, the temperature and rain, these are the two very important factor for climate. Then atmospheric pressure, wind, particularly the wind direction, wind velocity, humidity, and last but not the least, the temperature. I would like to put before you here measurement of climatic variables, and here you can see this the two sides. Generally we represent temperature in degree centigrade, on the other hand rainfall in millimeter, and now you can see through this diagram it is possible to show the month-wise mean daily maximum temperature, mean daily minimum temperature, and then the mean total rainfall through this diagram. So, looking this diagram, it is possible to see even seasonal pattern. This may change from place to place, from area to area, region to region. So, this type of diagram is a very common for understanding climatic variables, take into consideration of particularly these two variables, temperature and rainfall. Then I would like to explain little bit about these four important variables. Temperature, it is a physical property of matter that quantitatively expresses the common notion of heat, or particularly the hot or the cold weather. Quantitatively, temperature is measured with thermometers. Much of the world uses the Celsius scales, degree centigrade, generally most of the temperature measurement. On the other hand, precipitation, it is only a product of a condensation of atmospheric water vapor that falls under the gravity. There are many different types of precipitation like rain, snow, hail, and sleet. The standard way of measuring rainfall or snowfall is the standard rain gauge. So, any country or any region, region, you can find a network of the rain gauge station, for knowing the extent of rainfall, or the spatial and even temporal characteristics of rainfall can be examined taking into consideration of the data collected from these rain gauges. Third important factor is humidity. Humidity is the amount of water vapor in the air. Water vapor is the gas phase of water and is invisible. Humidity indicates the likelihood of precipitation, dew factor or the fog. There are three main measurement of humidity, like a absolute, relative humidity, and then a specific for a particular place. The device used to measure humidity is called a psychrometer or hygrometer. Then the next factor I would like to elaborate about the wind. It is a flow of gases on a large scale. On earth, wind consists of bulk of movement of air. In meteorology, winds are often referred to according to their strength and the direction from which the wind is blowing. Weather indicate the direction of the wind, and wind speed is measured by anemometer. Now I would like to discuss with you various factors influencing the climate. I would like to elaborate little bit these four important factors, just discuss earlier. A region's climate is generated by the climate system, which has the components. This include atmosphere, largely the gaseous elements, hydrosphere, the liquid and different type of the water system on the earth, cryosphere. This is a very, very important when we are looking the and analyzing and understanding in era of climate change, because cryosphere denotes largely the snow and the glaciated area. Then we have land surface, lithospheric aspects of our cycle, and then the biosphere, this the living organism on the earth surface. Climate of any particular place is influenced by a host of interacting factors. This include latitude. It's a very, very important factor. It influences the heat pattern, temperature, the rainfall pattern, elevation. That is a very, very important. With increasing elevation, one can see also changes in the temperature. Then nearby the water, also the water condition and surrounding water situation can influence the climate. Near, like sea, we have a different type of climate. Near river, we have a different type of the weather. Ocean currents, these are also very, very important factors. Topography is the relief features, particularly the visual features. Vegetation is very, very important, biospheric aspects of the hydrological cycle. This vegetation play a very important role for regulating our different cycles, and even our more specifically I would like to tell you the carbon cycles. So it is a very, very vital component of the whole climatic system. Then prevailing winds, the strong or then the direction of winds, these are also very, very important, particularly when we talk about the global climate and the global climatic circulation and pattern. Now I would like to elaborate little bit these factors, and when you see the latitude, I would like to tell you the surface temperature vary with latitude. That is a very, very important factors. Then elevation, climate zones coincide roughly with different elevation ranges also, and so that is why I would like to remind our viewers about altitudinal vegetational zonation model given by the CTRL. You can see that the vegetation varies according to altitude. Now we have in high altitude we have the alpine zone, then temperate, then we have subtropical and the tropical situation. This type of the so elevation and it is a very, very important factor. Then nearby water like sea surface temperature affect land temperatures. SST, sea surface temperature, that is considered is a very, very important measurement for understanding even the climate change, climatic surface. We are living in a monsoon land, and where even the sea surface temperature, direction of wind, the moisture content can influence our whole climatic system of the subcontinent, and what we get, it is known as monsoon. Then ocean currents, water temperatures indicate transfer of heat energy by the currents. So heat energy is a very, very important, again, particularly regulating the whole climatic cycle. The word climatic model depends upon this type of the heat transfer. Ocean may be considered is a very important aspects of the carbon activity, and even as a very important platform for understanding the different type of the cycles, nutrient cycles, and maybe particularly more the sedimentary cycles. Then we have topography. Local variation in elevation can cause local variation in the climate, and so that is why topography, even with short distance, one can see a lot of changes in the climate due to the different topographic conditions. Vegetation, very important factor, type of ground cover, even the seasonal changes affect the climate. We have a different type of the high density forest, low density forest, sparse vegetation, and this all influences our climatic system. Then we have prevailing winds. Winds deliver air masses and particularly with a specific property, and when we see and analyze the global in subsequent 2 days, largely we are going to discuss with you the several type of prevailing winds. Now I would like to discuss with you the different atmospheric components. Among all the components of the climate system, the atmosphere is the most active component. That is why it has the most noticeable impact on the weather and the climate. Now you can see here, it is generally represented through the parts per million by volume, and in nutshell what I would like to, now you can see here the different type of gases, but the nitrogen consisting of almost 78% and oxygen almost 21% of the whole atmospheric composition. So these two are the vital gases of our atmosphere, nitrogen and oxygen. Then then we have several other, methane, helium and other gases, but I would like to, nitrogen dioxide, I would like to tell you the water vapor, that is also the very, very important component, and almost it varies between 1 to 4% of the total surface by the water vapor, and even the climate change also, the water vapor play a very important role in regulating the whole our climate and understanding the climate change. I would like to summarize the earlier climatic composition given just now. Earth atmosphere is very thin layer wrapped around a very large planet. So biospheric aspects of hydrological cycle, this is a very, very important aspects. Two gases make up the bulk of the earth atmosphere, like nitrogen, which comprises 78% of the atmosphere, and oxygen, which accounts for 21%. Various trace gases make up the remainder of the gases. Based on temperature, the atmosphere is divided into the 4 layers: troposphere, So, starting from the earth surface, the troposphere, then we have the stratosphere, then mesosphere, and then thermosphere. Energy is transferred between the earth surface and the atmosphere via conduction, convection, and radiation. Ocean current play a very significant role in transferring this heat poleward. So, conduction, particular molecule to molecule, you can see this is the very classic generally example we used to give, that if the heated iron and if you will keep from the other side, our hand also gets some heat. So, largely this type of process is considered as a conduction, but convection on the other hand, it passes through this the liquid and the gas and radiation, that's solar radiation, that is a very very important component, because whatever the energy our earth surface get coming from the changing input from the sun, and any changing input from the sun can influence our climatic pattern. So, that is why I would like to emphasize very quickly here that climate change is a synthesis of also changes in the natural factors, like a mountain building process, earthquakes, volcanoes. These are the some of the changing input from the sun, these are the some of the factors, together with the various anthropogenic factors and the human activity starting from agriculture to industrial development. Based on the temperature energy, the major currents such as the northward flowing Gulf Stream transport tremendous amount of heat poleward and contribute to the development of many types of the weather phenomena, which will be described tomorrow in more detail and day after tomorrow. Now, I would like to discuss with you the temperature in the atmosphere, and particularly I would like to suggest that you can see the diagram given on the slide. Through this diagram you can find that how temperature decreases in troposphere with increase of altitude. Then in stratosphere you can see again increasing with increase of altitude. Then you can see this in mesosphere decreasing, and then again in thermosphere increasing. So, it is a very very typical phenomena one can see here, that relationship between the temperature and the altitude. Through examination of measurements collected by radio sound and aircraft and later by rocket, scientists became aware that the atmosphere is not uniform. Many people had long recognized that temperature decreases with altitude, and through this diagram one can see a very clear cut picture denoting the decrease of temperature, increase of temperature through the increase of the altitude. In the early 1900s, that radio science revealed a layer about 18 kilometers above the surface, where temperature abruptly changed and began to increase with altitude. The discovery of this reversal led to division of the atmosphere into the layers based on their thermal property. Now, through this diagram, this one is a more clear cut picture about the more details about the layers of the atmosphere and the various associated activity. Now, you can see here the satellite, satellite passes through almost the between 800 to 1000 kilometer from the earth surface. Spacecrafts little bit on the lower distance than the satellite, and then we have the various type of supersonic jets and the aircrafts, balloons in a different zone. So, one can see here through this diagram the different layers of atmosphere starting from troposphere to thermosphere. Then we have how the temperature increasing and decreasing with the altitude. On the other hand, we have also the various economic activity, human activity, anthropogenic activity. These activity influence also our climatic, as you know, CFCs and the 11, 12, these are also influencing. We will discuss at the end of our discussion. Another vital element here I would like to discuss with you, the ozone layer. It is contained within the stratosphere. In this layer, ozone concentration are about 2 to 8 parts per million, which is much higher than in the lower atmosphere, but still very small compared to the main components of the atmosphere. It is mainly located in the lower portion of the stratosphere from about 15 to 35 kilometers. Though the thickness varies seasonally and geographically, about 90% of the ozone in our atmosphere is contained in the stratosphere. This is a very important, because this ozone layer is considered as a very important layer for protecting ultraviolet rays coming to the earth's surface, because with impending degradation of ozone or depletion of ozone layer, we are also getting variety of problems on the earth's surface, on agriculture, on our human health, on variety of human activities are influenced by the depletion of the ozone layer. Now, I would like to discuss with you the very important tricellular model of atmospheric circulation. Now, you can see this, the polar front, both sides, south pole or the north pole. Then we have the three cell, polar cell, then Ferrel cell and the Hadley cell. Here I would like to emphasize very clear cut picture you can get here, that the subtropical high pressure in ITCZ, and how the wind pattern, that is a very important, and this wind pattern will influence our climatic system all over the globe. So now you can see this is how in the north pole, from the south northeast side to the southwest direction, but on the other hand, if you will see in the south pole side, then you can find from southeast to northwest direction, and then both side you can of the ITCZ you can find this type of wind changes in the wind pattern. This is a very important aspects for understanding the climatic circulation and even our monsoon pattern. Measuring the atmosphere, measurements such as temperature and pressure not only help us to predict the weather, but also help us to look at long term changes in the global climate. The two most important instruments for taking measurements in the earth atmosphere were developed hundreds of years ago. You might have heard the name of Galileo, is credited with inventing the thermometer in 1593, and then E. Torricelli invented the barometer in 1643, particularly measuring the pressure. So, with these two instruments, temperature and pressure could be recorded at any time at any place. These two very important and very long back, even thermometer in 1593 and then the barometer in 1643. We now have a continuous satellite monitoring, because after the post 70s, more specifically I would like to highlight, we have several satellite measurements. The for atmospheric measurement we have the specific aircraft, satellites are there. Particularly, I would like to take the name of NOAA satellites, and we are getting, and at any place and even at your laboratory you can get the NOAA receiving through. If you have a NOAA receiving station, the continuous the data transmitted and can be stored in your computer, and then we can analyze. Now I would like to take the another factor, particularly the pressure in the atmosphere. Atmospheric pressure can be imagined as the weight of the overlying column of air. Unlike temperature, pressure decreases exponentially with altitude. Traces of the atmosphere can be detected as far as 500 kilometers above the surface of the earth, but 80% of the atmosphere mass is contained within the 18 kilometer closest of the surface. So, this is a very, very important. Now, through this diagram you can see the relationship between pressure and then the altitude. Now, you can see here how the pressure decreases with altitude, increase of altitude. This diagram is a very clear cut diagram. One can see here that how atmospheric pressure decreases with altitude. In lower altitude we have the high pressure, but in the high altitude we have the low pressure. So, one can see atmospheric pressure is generally measured in millibars, that you can see in this, explained in this diagram, and this unit of measurement is equivalent to 1 gram per centimeter of the square. Now, I would like to bring before you another very important component, atmosphere and ocean interaction. The exchange of heat and the moisture has profound effect on atmospheric processes near and over the oceans, and so that is why you can find the surrounding to our India, we have Bay of Bengal, Indian Ocean, and the heat pattern, sea surface temperature all influences our climatic system of the subcontinent. Ocean current play a significant role in transferring this heat poleward. Major currents such as northward flowing Gulf Stream transport tremendous amount of heat poleward and contribute to the development of many types of the weather phenomena. The ocean cover nearly 3/4 of the earth's surface and play an important role in exchanging and transporting heat and moisture in the atmosphere. Most of the water vapor in the atmosphere comes from the ocean. So, that is why I told you in the beginning that water vapor we do not consider the much very important, but it play a very important role in this the whole climatic circulation. Most of the precipitation falling over land finds its way back to the ocean. So, you can see this the whole hydrological cycle. These hydrological cycle play a very important role for this. Now, I would like to discuss with you function of the atmosphere. Protection of all life form from hazardous or deadly radiation from space, because it filters ultraviolet and X-ray from the sun. So, the most important function of atmosphere, so atmosphere is a very very important component for even for the human health. Letting pass the vitally component sunlight to the surface of the continents and the ocean, and that is the energy, because the important energy source we get is a solar energy and passing through the atmosphere, and in this we have a several processes: absorption of energy, reflection of energy, radiation of energy, scattering effects, variety of several mechanisms mechanism is operating in this the whole atmospheric processes. Protection from rapid cooling at night and heating at day, that is a very very important, this atmosphere play a very important role. Then it play a very important role for transport of energy, warmth of air that can be felt, and latent warmth of water vapor from the equatorial regions to medium and the higher latitudes. Then transport of water vapor through dynamic processes of general air circulation that determine also precipitation. So, rainfall pattern also determine on the basis of this the water vapor transportation, then evapotranspiration processes where the vegetation play a very important role. Then a storage of the huge amount of nitrogen, important for plants. This this is a very very important aspects of our hydrological cycle, and the ocean play a very very important and the atmosphere. Reservoir for dissipation and decomposition, particularly oxidation, reaction with radicals, photolysis of natural and anthropogenic emissions. Last but not the least, protection from a smaller meteorites that burn up by heating from the friction when entering into the earth's atmosphere and cannot reach to the surface. So, it protects from these meteorites. Now, I would like to deal climatic classification, particularly for geographers and even for the many environmental scientists. It is very important to know different type of the climatic classification. There are several ways to classify the climates into the smaller regimes. Classification is a generally for identification of homogeneous area, taking into consideration of the climate, vegetation, depends upon the different methods. Modern climate classification methods can be broadly divided into the two methods: genetic method, which focus on the causes of the climate, and the empiric methods, which focus on the effect of the climate. So, causes of the climate and then the effects of the climate, and generally the most of the classification coming from either of these criteria. A common shortcoming of this classification scheme is that they produce distinct boundary between the zones they define, rather than the gradual transition of climatic property more common in nature. So, if you see you can find this the temperature or the rainfall pattern, not a very clear cut boundary, but in classification we have to classify taking into consideration of the spatial element. Most common climatic classification are like a Köppen, Thornthwaite, Trivartha. First, I would like to take up the Köppen climatic classification, most widely used climatic classification system of the world. Later on, various scholars also modified this classification. The system is based on the concept that native vegetation is the best expression of the climate. Thus, climate zone boundary has been selected with vegetation distribution in mind. So, here one can see a very close context between the climatic zone and then the vegetation, and one can see a lot of also, and so that is why the sea trawl, one scholar developed a very important theory that vegetation varies according to altitude. This method combines average annual and monthly temperature and precipitation and seasonality of precipitation. Then the most common used form of the Köppen classification has been 5 primary. He identified the 5 primary types: A, tropical; B is a dry climate; then the C is a mild mid latitude; D is a cold mild latitude; and then the E, the polar type. Then you can find the sub classes also within this. The Trivartha climate classification scheme is a modified version of the Köppen system as an answer to some of the deficiency. It attempts to redefine the broad climatic groups in such a way as to be closer to vegetation zoning. So, Trivartha classification, one can see a very closer to the vegetation zoning, and so that is why is also the more popular. Through this diagram, I would like to explain about this, the world map of the climate, and later on the Geiger modified this, and so that is why it is known as the Köppen-Geiger climatic classification. Now you can see in this, the tropical area we have the A category, then both sides of the tropical, one can see the dry, particularly consisting of Africa, and then the part of Australia, Middle East part. Then the sea, the mild mid latitude, just above both sides. But then on, if you go to the more upper part, one can see the cold mild latitude, and then finally both side you can see the polar region. So, here one can see a very, in case of India also one can see a lot of the also the dry together with the some of the mild this mid latitude and the cold latitude factors are also. So, within Indian situation one can see the tropical, dry, and one can see a very combination of various type, and more specifically tropical, then the dry climate, which may be considered a more mixed type of the, because the one can see a mixed vegetation also, and then also the some cold in some part. Thornthwaite climatic classification. This climatic classification method monitors the soil water budget using the evapotranspiration. So, most important factor taken into consideration by Thornthwaite is a evapotranspiration. It is very important also for India. We have the more dry, more rain fed area, 68% area you can find this where precipitation is less than the potential evapotranspiration. So, it monitors the portion of the total precipitation used to nourish vegetation over a certain area. So, the vegetation factor taken into consideration. It uses indices such as humidity index and aridity index to determine an area moisture regime based upon the average temperature, average rainfall, and average vegetation types. Then another important characteristics is a lower the value of the index in any given area, the drier the area is. That is a very important characteristics of the Thornthwaite climatic classification system. Thermal classification within the Thornthwaite scheme include the microthermal, mesothermal and megathermal, largely taking into consideration of the factors at a macro level, meso level and the more local or the micro level. I would like to put before you the climate regions of India here. The most important region, you can see this the highland in the upper part, the western side and also the eastern side. So, western Himalaya and then the eastern Himalaya. Then we have the more humid subtropical type, and humid subtropical type one can see, this the whole Indus, Ganga and Brahmaputra valley, this type of the the climatic system. Then we have semi-arid, and semi-arid we can see also along the Rajasthan, and then it also reaches towards the Karnataka. Then we have the arid, largely part of Gujarat, and then I would like to explain that 12 district west of Arauli, that may be considered as a more the arid type of the. Then tropical wet again in some part of the peninsular India, and then tropical wet and dry, and but Western Ghat giving us the more tropical wet type of the and you can see this it is very famous particularly for the typical type of vegetation pattern in Indian climatic situation. So, you can see here in India we have a mix of climate starting, and so that is why we have the alpine on the upper reaches in the Himalaya. Then we have a temperate zone, then we have the subtropical and the tropical, and within the tropical subtropical one can see the more dry and the wet situation in between. But the Indian climatic system is a combination of the variety of the dry and wet. I would like to also through this diagram I would like to explain about the interaction among the different component of climate system. Now, you can see here the water cycle, then the human factors, driving factors, different type of industry, transportation, rapid urbanization, this all influences our climatic system. Then the ecosystem functioning and the structure, the vegetation pattern, the density of vegetation, these are the very, very important factor influencing our climatic system, and then the carbon cycle. So, now taking into consideration of this, and ultimately we are getting the solar input. So, the natural factors, the changing input from the sun, and then this mountain bending process, the volcanoes and the earthquake activities are also influencing our climate system. On the other hand, the human activity, intensive human activity in the post 1950 era, you can find the massive industrialization has taken place in India, and then the urbanization, mega cities growing at a very faster rate, and then we have tremendous change in the hydrological cycle, runoff pattern, even infiltration system and pattern. Finally, I would like to also discuss with you this different agency for the climate atmospheric research. At a global level, we have World Meteorological Organization, and then we have WCRP, World Climatic Research Program. IPCC is a part of that Intergovernmental Panel on Climate Change. Then National Aeronautics and Space Administration, NASA, own satellites are there, meteorological satellite. Regional level we have APEC Climate Center, but in India we have India Meteorological Department, IMD, Indian Institute of Tropical Meteorology, IITM. These are the two very important, very active and contributing to the monitoring and forecasting of our weather and climate. Thank you, viewers.
Okay. Thank you so much for the wonderful lecture. I heard your lecture throughout the hour, and I heard that there is some climate change in Delhi as well. So, is there any signs or signals for the climate change in Delhi?
Yes, very good question. And I would like to tell you that if you analyze the data, two very important components depict the climate change, and one can understand temperature and rainfall. Particularly temperature, I would like to tell you. We analyzed the data for few years and we found that changes in the increasing. But I would like to tell you this is a more microclimate change.
Okay.
Microclimate change. But second aspects I would like to emphasize. Now we are just entering into the winter time. In winter time in Delhi, generally we used to get earlier western disturbances induced rainfall around 2-3, maybe 10 years back or the 5 years back. But in last 3-4 years, we are getting the western disturbances induced rainfall almost 6-7.
Okay.
So this frequency of western disturbances induced rainfall is increasing.
Yeah.
And then also earlier we were getting only until March, but now it is also extending until the May
and August as
yeah
well.
So what I would like to tell you, a lot of people are doing research, but even people are doing research and that even long range monsoon system can be also affected, but it requires a lot of careful long term data analysis and geographical inquiry.
Okay, as we have seen that so many storms occurred in Assam and as well as in America as well. So what would be the climate change in that particular region or area? How does it affecting that area?
Particularly the flooding.
In India as well as in other countries.
Flooding is also one way you can see that one can relate. I would like to bring before you here the factor upstream and downstream relationship. Like in upper reaches, we have the change in the climate, and climate is changing everywhere, but particularly that change is influencing the snow and glaciers.
Okay.
And due to the melting of glaciers, we have high flow during the monsoon time. So that is a very, very important one aspect. But the second aspect I would like to emphasize also anthropogenic activity, deforestation. Okay. And so that is why we have the more runoff. So the rainwater comes very quickly to our river system, Indus, Ganga and Brahmaputra system, and then we are very frequently flooded.
So global warming is also one of the factors among all.
Global warming is a lot of research is going on, and one can see a lot of the comparison between the global warming phenomena and also the flooding. Even maybe we'll highlight in the subsequent lecture. Okay. El Nino and factor and all long range. These are very much related to the dry, and sometimes used to bring the drought. Sometimes used to bring the La Nina factor used to bring the flood.
Okay. That would ozone layer is decreasing and.
Yes, that I discussed also today. Yeah. A little bit about this ozone layer. That is a very, very vital, because ultraviolet. If something happening to the ozone, ultraviolet rays reaching to the Earth's surface means causing harm to even the human body. Then also to lot of agricultural activity on the biodiversity, influences on biodiversity. So that is why, due to the CFC 11, 12, various factors are operating, and this ozone layer is being stratospheric. I would like to specifically take the name of stratospheric ozone is being depleted. That is a very, very vital layer of our atmosphere.
Okay, sir, I would like to ask one thing, that when winters start coming, it's hit the Delhi. That particular week, we have seen so much fog and smoke all over the Delhi region. So, what would be the reason behind that?
Yeah, just last week also we had this phenomena.
Yeah.
Smog.
Smoke. Yeah.
Smoke and the fog is a mixture.
It was a
mixture of. I would like to again relate with the climate change. How?
Okay.
That this whole Indo-Gangetic plain is a very, very highly intensive land use activity. Aerosol concentration, the fossil fuel, even in Delhi, a lot of people also in surrounding to Delhi we use. Then also I would like to tell you, we have in surrounding to Delhi, we have the lot of irrigation, irrigated area, and due to the irrigation we have also the more moisture content, and this moisture content remain in the atmosphere for a long, and then this then smokes and this all mixing up. I would like to tell you that the lot of work done, UNEP, United Nations Environment Program, also tried to do, still they are not able to come on a very concrete conclusion, but these are the some of the the factors generally one can relate with this type of pattern.
So maybe that was the reason, for that, maybe pollution.
Pollution is very, very important. Now we have many initiatives in Delhi, and I would like to tell you that one can see, if you compare the 15 years back and now, we have a change. Pollution level gone down in several places, but still pollution level is very high because of this, the very heavy concentration of population, and more specifically the vehicle. 70% of the pollutants, generally in Indian city, we consider coming from the vehicles. And people, here I would like to tell you this, the role of public transport system is very, very important. In Mumbai, even people are having the vehicle, but they do not go for office with vehicle.
They use public transport.
Generally public transport system, better public transport. I would like to compare with Tokyo. Tokyo is a more population than us. Seoul, greater Seoul is a more population, if you say, but they do not have a problem because people use the public transport system like metro. When we have this, the network of the metro system all over the city, I think we'll have a very substantial improvement in the situation.
Even with this connection to the question, I would like to ask, from the day our Honorable Chief Minister has announced that CNG should be mandatory for all the vehicles.
Yes.
So still we are having in a Delhi region, still we are having Delhi's more polluted region in the country or city in the country.
Not very means polluted, but we have pollution. Also
CNG is also
but you see, not only CNG, I would like to bring before you some factors. CNG is one. Then we have shifted some polluting industry from core to the peripheral area like Bawana and second. Third one, metro, construction of the Delhi metro system. Fourth one, the plantation. Few years back we have only 7-8% area under the vegetation cover in Delhi. Now almost we have more than 18-19% area under the vegetation cover. Then flyover, construction of the flyover. also very important in case of Delhi, because when vehicles are running fast, there will be the less concentration of pollution.
Okay.
Huh.
Okay.
So construction of flyover is also very, very important.
Okay, so I have to wrap up the lecture, and so that we can continue this lecture tomorrow. Thank you so much for coming here and giving such a wonderful lecture. And I hope this lecture must be interactive and very useful for you all. So thank you so much, and thank you, sir.
Thank you, madam. Thank you.